Welcome back to Naruto Masters Academy. We are in module 4. We will discuss today in this session law of constant proportion and a few numericals based on this concept. So this law of conservation of mass we have discussed in the previous session, and today we will discuss about law of constant proportion. So this law of constant proportion is given by, look at here, the Proust, the scientist Proust in the year of 1779. Okay, so what it indicates actually, according to the law of constant proportion, if you take any molecule and in that molecule, wherever you will find the solution, always the proportion is constant. So let's today see here, and a chemical compound always consists of a same element combined together. Look at here, a chemical compound always consists, for example, if you see water molecule, water's chemical formula is H2O. Wherever you find the water, in river or pure water or distilled water, whatever it may be, water chemical formula is always same. Is it right? It means the proportion of these two elements, hydrogen and oxygen, is always in the constant proportion according to their masses. A chemical compound always consists of the same elements combined together in the same proportion by their masses. Okay. Now we'll discuss here in this with neat example about it. Okay. Now he analyzed the chemical compositions of a large number of compounds and came to a conclusion that the proportion of each element in a compound is constant. Okay. Now look at here, law of constant proportion. According to the law of constant proportion, a chemical compound always consists of the same elements. Any chemical compound, if you take, always it consists the same elements. Okay. If you say carbon dioxide, always it consists of carbon and oxygen only. Either if you take 10 grams, either if you take 20 grams, 100 grams, there is no change in the proportion of carbon and oxygen. If you take 1 liter water, in that the amount of hydrogen and water is also equal to if 5 liters water, same proportion, not same amount, same proportion of hydrogen and oxygen. There is no change in the proportion of their masses. So the amount of mass of hydrogen which is present here and oxygen which is present here, if you multiply 5 times of those masses gives 5 times of water liter, means water. It means same elements throughout the solution or throughout the compound and is not changing at all. Is it right? If you take 1 liter or 10 liter or 50 liter, the proportion is constant throughout the substance. Now combined together in the same proportion by mass. If you see here, ice water, H2O, chemical formula is H2O. And here is the question, how you got 1:8. Atomic number of hydrogen is 1 and its mass is also 1. Okay, how many hydrogens are there here? So hydrogen is H, 2 hydrogens are there, 2 into 1 gives equal to 2 grams. Okay, 1 hydrogen 1 gram, 2 hydrogens, 2 into 1 is 2 grams. And oxygen is, atomic number is 8, its mass is 16 grams. How many oxygens are there? Only 1. How many hydrogens are there? 2. So 2 grams of hydrogen requires how many grams of oxygen? 16 grams. 2 ones are 2 eights are. So what is the ratio of hydrogen to the oxygen in the water? 1:8. Very, very important. Okay. Atomic mass of hydrogen is how much? 1 gram. How many hydrogens are there? 2 hydrogens. So 2 into 1 is equal to 2 grams. For 2 grams of hydrogen, how many grams of oxygen is required? Atomic number of oxygen is 8 and its mass is 16 grams. How many oxygens are there? Only one, so 116. So for 2 grams of hydrogen, 16 grams of oxygen is required. It means to 1 times to 8 times. So what is our mass ratio here? If hydrogen 1 gram, oxygen 8 grams. If hydrogen 10 grams, oxygen 80 grams. If hydrogen 11 grams, oxygen 88 grams. Okay, multiply 1:8 ratio. Remember, very, very important. Now, here it is ice water and here it is river water. Is there any change in water? Is there any change in chemical formula? Is there any change in the mass ratios? No. Wherever if you find this water, the always either in the form of ice, either in the form of liquid river water, either in the form of sea water, either in the form of sea water, always same. Okay, always same throughout the solution. Okay, very, very throughout the substance here, solution in the sense sea water and river water, ice water. In all cases, the mass of hydrogen to the oxygen is not changed. It is same. Okay, here is the question. What is the compound which always consists of the same two elements? Hydrogen and oxygen. Okay. Now, if you see again here, yeah, let me check once. They combine together in the same constant proportion of 1:8 by mass. So 1 gram of hydrogen requires how many grams of oxygen? 8 grams. Okay, very, very important. Now look at here, hydrogen. So this process is, we call it as decomposition of water. What we call it is decomposition of water. Once you decomposition of water. If you want to decompose the water, so basically what is the chemical formula of water? H2O. So here it is in the form of AB. Assume it as A and B together. Decomposition reaction is nothing but splitting of a reactant into two different products, A and plus B. So here H2O gives rise H2 plus O2. It is not balanced 2 times of H2O. So 2H2 plus O2, 2 into 2, 4 hydrogens plus 2 oxygens. Now here H2O is A into B, A, B. And here hydrogen is A and oxygen is B. It is decomposed now. Decomposition means splitting. Okay. So with the help of external source EMF, battery EMF in the form of cathode and anode rays, anode rods, cathode rod and anode rod. Positive rod is known as cathode rod and negative rod is known as anode rod. So here, if you see this water, it is electrolyzed. What we are calling here, it is electrolyzed now. Now, if you see here, okay, if we decompose 100 grams of pure water, how many grams of pure water? 100 grams. By passing electricity through it, then 11 grams of hydrogen and 89 grams of oxygen are obtained. But is there any change in the mass ratio here? No. For 1 gram, 8 grams. For 11 grams, 88. So almost it is 88 or 89. Total is 100. Is it clear? So 100 grams. Now, if we repeat this experiment by taking the pure water from different sources like river, sea, well, etc., do you think the mass of hydrogen and oxygen changes? So the same masses of hydrogen and oxygen elements are obtained by river water, sea water, or well, wherever you will go. The ratio of hydrogen mass to the oxygen mass is same. Okay, remember this. This experiment shows that the water always consists of the same two elements. What are those two elements? hydrogen and as well as oxygen combined together in the same constant proportion of 11 is to 89 or 1 is to 8 by their masses. Now, question very simple. Calcium carbonate. Chemical formula of calcium carbonate is CaCO3. Is decomposes means splitting. So this is AB. Now to split into A plus B. To form calcium oxide, here it is formed calcium oxide and carbon dioxide CO2. When 10 grams of carbonate, which carbonate? Calcium carbonate. It is 10 grams total amount AB or calcium carbonate is decomposed completely. Then 5.6 grams of calcium oxide, 5.6 grams of calcium oxide is formed. Calculate the mass of the carbon dioxide formed. Here the mass of carbon dioxide is question mark. Which law of chemical combination will be used in solving this problem? Very simple. The name of the law is law of conservation of mass. According to the law of conservation of mass, mass is neither created nor destroyed. It means here it is, assume it as x. Okay, so 10 is equal to 5.6 plus x. Then x is equal to 10 minus 5.6. How much it is? 4.4 grams. 4.4 grams of what is that? CO2 is obtained in this reaction. Is it clear? Do you want to see the solution? Very simple. Look at here, solution. This problem is to be solved by using the law of conservation of mass in chemical reaction. Calcium carbonate is the reactant, whereas calcium oxide and carbon dioxide are products. Now, from the law of conservation of mass, we have the mass of product should be equal to mass of reactants. Is it right? Now, mass of calcium oxide plus mass of carbon dioxide together, how what? Mass of calcium carbonate. So here, mass of calcium oxide is 5.6, which is formed in the chemical reaction, and the mass of carbon dioxide is unknown, and that mass of these two substances together is how much? 10 grams. So mass of carbon dioxide is equal to 10 minus 5.6. That equal to how many grams of carbon dioxide is formed here? Thus, the mass of carbon dioxide formed is 4.4 grams. Is it clear? So very, very important. So with this, what we have finished? Law of proportion. So far, we have finished two concepts. First one is law of conservation of mass. Law of conservation of mass. And second one is law of constant proportion. Constant proportion. Okay, very, very simple topics, very, very important topics which you have covered so far. Next concept is atom and Dalton's atomic theory and their symbols. Okay, atom, Dalton's atomic theory and the symbols of elements. Okay, we'll discuss now. Atoms, Dalton atomic theory and symbols we'll discuss here. Do you know what is atom? Yes, so all the matter is made up of an atom, and whereas atom is the smallest invisible particle. Yeah, very good. Look at here. All the matters is made up of an atoms, and these atoms are building blocks of an all the matters around us. Okay. Now, An atom is the smallest particle of an element that can take part in the chemical reaction. Atoms are very, very, very small in size, invisible size. The size of an atom is indicated by its radius called atomic radius. Okay, atomic radius is measured in nanometer. Nanometer in the sense 1 nanometer is equal to 10 power minus 9 meters. Okay, and the atomic exists combination with the atom of same elements or another element. Very, very important point is the atomic exist combination with the atom of the same element or another element. Okay, atoms of hydrogen is smallest at all. Which atom of element is very, very smallest? Atom of hydrogen is smallest at all. Okay, symbols of some elements. At that time, only few elements are discovered and their symbols also, but they never in use now. They are not in use, but those symbols are there in the history. Okay, so remember what are those symbols and the elements. The symbols of elements, it means the symbols of the atoms. Okay, element symbol is nothing but atom symbol of the elements, because elements are made up of an atoms. Every element is made up of atom only. It means if you are if you're defining an element with the help of symbol, that automatically you are defining for atom as well. Okay, remember that. We will first discuss the Dalton's symbol of elements and then the modern symbols of elements. Okay, Mr. Dalton, the scientist. Dalton was the first scientist to use the symbols for elements in a very specific sense. So initially, he started using the symbols for those elements, and they are in history only. In modern science, we are not using those symbols. Now, the sensitivity, very, very simple symbol of hydrogen. One circle with dot is the symbol of hydrogen, and carbon, it is fully dark as in the carbon, what we call a lead color. And next is oxygen, a halo circle. And next is phosphorus, a benzene, what we call Mercedes Benz symbol for automobiles. Okay, three lines joined together. Next is sulfur, you have emergency symbol like plus symbol. Okay, inside the circle, all in the circle itself, but they are having different colors or different symbols in that circle. They are not in use now, they are in history only. Next, iron with circle and one I indicates iron. And copper C. And here is the question, it will come in mind. And here lead is L, copper is C, iron is I, etc. Very good. Now silver, yes, don't write yes for sulfur. For sulfur, emergency symbol, plus symbol. And for gold, circle with inside a small like watch, and then that is G for gold. And platina, P, lead L, platina P, copper C, silver S, iron I, all with circles only. Gold Z with dotted lines inside. And mercury, only dots inside. There is no symbol for mercury. Okay, these are the some symbols. Dalton symbols for elements were difficult to draw and inconvenient to use. It is very difficult to draw them and inconvenient to use, and it is very difficult to remember as well. Is it clear? Very, very, very important. Remember these. So Dalton symbols are only of historical importance. They are not used at all. So these symbols we are not using at all, but these are historical symbols which we have to remember. Okay, very, very important as well. Now you can see here, now modern elements or modern symbol of an elements. Modern means presently which we are using here. The symbol of an element is the first letter or the first letter and the another letter of the English name or the Latin name of the element. For example, if I want to write the symbol of an element, hydrogen, can you guess what is the symbol? You know very well spelling of hydrogen. Hydrogen, and its symbol is H. So what we can conclude from that? First letter of the element. What is the first letter of hydrogen? He. Or first letter and another letter. For example, copper. Cu. First letter along with that another letter. U is not there. The name of the copper is, we'll call it as cuprum from Latin name. If you want to see calcium, its symbol is Ca. How many letters are there? First two. Rather than only one, for some elements, we are having two symbols, two letters, either first and second or first and third. If you see lithium, its symbol is Li. Okay. Now, first two only there. And sodium, its symbol is Na. Completely different here. There is no first letter, there is no second letter, there is no third letter. And this name of the sodium is, Na is nothing but the name in the Latin of that sodium. Okay, we'll discuss those things here now. The symbol of hydrogen is H, first letter of the name, and symbol of oxygen is O, first letter of name. And do you think there are, however, some elements whose names begin with the same letter? Very important. Carbon, calcium, chlorine, and copper. Okay. Now, if you see, in such cases, one of the element is given as a one letter symbol like copper. Carbon is given, its symbol is C. That's it. And next to first letter of names, it is the first letter of name. Remaining three, they are having different names again. But all other elements are given two letter symbol. Calcium Ca, first two letters, first and second letter of and name. And third one, please note that this another letter may or may not be the second letter, may change. Keep it in mind. What is the symbol of chlorine? Cl, and the first and third letter of the name. The two letters are this first letter and another letter of the same English name or Latin name of the elements. So here we have to remember second letter is not compulsory to write first or second letter in the name. Chlorine. What is the position of L? Third. What is the position of C? 1. Okay, 1 comma 3 here. Okay, first letter and third letter. If you see calcium, first letter and second letter. Okay, very important. It's not necessary that to write only first and second. It is not necessary to write only first and third. And we are having different as well. Potassium Na, potassium K, sodium Na. Like that we are having. Is it right? For sodium Na, for potassium K. Like that different element symbols also there. Very important. The symbol of copper is Cu, and here there is no U in this letter word copper. So C is the name of the copper, cuprum. Name in Latin is cuprum, Cu. Okay, and in the next session, or now let me continue in this session itself, elements and their symbols. Note down those symbols. It should be noted that in a two letter symbol of the first letter is the capital letter, but the second letter is always smaller letter. So if I'll ask you to write helium, don't write He like this. It is not helium. Always remember, out of those two letters, the first letter is always a capital letter. Always how much? First letter is always a capital letter, and the second letter is the small letter. Okay. Helium, lithium, sodium, magnesium, calcium. If you observe these all, copper. What about the first letter and second letter? First letter, second letter, first, second, first, second, first, second, and first, second. First letter is always capital letter, and the second letter is always small letter. Very, very important as well. Remember this point. Now note down this all. Element name in English and symbol. Hydrogen, its symbol is H. And next helium, its symbol is He. Lithium, Li. And boron, B. And then carbon, C6, that is carbon, C. And nitrogen is N. Oxygen, O. Okay. Now again, few more elements. Fluorine, F. And then neon, Ne. Okay, not N. For sodium, we give Na. Okay, neon is Ne. And next is magnesium, Mg. And next is aluminum, Al. And next is silicon, Si. And phosphorus, P. And sulfur, S. Okay, these are the some elements and their symbols. Very, very important. Now, if you notice here, few more elements are there with their symbols. Chlorine, Cl, argon, Ar, calcium, Ca, magnesium, Mg, manganese, Mn, nickel, Ni, and then zinc, Zn, not Zi. Okay, very, very important. Zi is not the zinc here, Zn is the zinc. Okay, bromine, Br. Okay, krypton, Kr, xenon is Zr, iodine, I, at the same time barium, Be, barium is Ba, okay, and cobalt, Co, at the same time uranium is U, okay, very, very, very important chemical formulas and their symbols. In our study of chemistry, we use the English names of elements, so we are not familiar with the Latin names of the elements here. The most of the confusion there, therefore, arises in the symbols derived from the Latin names of the elements. For example, if you see sodium, so according to the spelling of sodium in English, we should write S, but the symbol of sodium is Na. Is it right? Can you guess what is its name in the Latin name? Natrium. Okay, natrium. And then after sodium, what we should get? Potassium. Potassium K. Okay, kalium. What is its name in the what we call a Latin name and English name? In English name, we'll call it as potassium. In Latin name, we'll call it as kalium. Okay, kalium is very, very important. Next to iron. Iron symbol is F, and we'll call it as ferrum. What is the name of the iron? Ferrum. Okay, remember, very, very important. Copper. Copper, Cu. Its name is cuprum. Latin names: natrium, kalium, ferrous, cuprum. Silver, yeah, Az is the silver name. Az is the scientist name here. And argentinum, okay? Argentum is given here the name of the silver. Argentum means Ag. Okay, very, very important. Now, What do you think about gold? We know the chemical formula of gold is AU. Is it right? AU. So how you will get this AU directly? Gold, its atomic mass is, if you take that much, that only. But here the question is symbol of gold. Gold symbol is AU. Aurum. Is it right? Aurum or aurum is the Latin name of the gold. AU. Now one more task. Mercury, and we'll use the symbol for mercury is Hg. Is it right? And the Latin name of the mercury is hydrogram. Okay, very important. Hydrogram means hydra in the sense Hg, mercury. You have to remember. Lead. Okay, I think gave in the list plan. Okay, so lead. Its symbol is Pb. Lead is Pb. Then plumbum. What is his full name in Latin? Plumbum. Plumbum is the full name of the that lead. Tin. Tin is Sn. Okay. Sn stantanium. Okay. Very important. Latin names and the symbols of the elements here you can see. Please note down these all. Sodium, natrium, symbol is Na. Silver is argentum. Argentum means silver is Az. Next, tungsten. Tungsten is wolfram. Okay, wolfram will use there. Tungsten symbol is W. And then potassium. Potassium is K. So kalium. And its symbol is K again. Okay, potassium symbol is K and its name in the Latin is kalium. Very important. Copper. Copper is, we know very well, cuprum. We'll call it as in Latin is cuprum. Its symbol is Cu. Okay, and next is gold. Gold is aurum. Is it right? Au. Gold is aurum. Au is a symbol. Iron. Iron, its name is ferrum. Okay, or ferrous. Ferrum. So that is the name in the Latin. Okay, ferrum. And its symbol is Au. Au is given already gold. Iron is Fe. Ferrum means. Okay. Last, lead. Lead is plumbum. Okay, its mass is, or symbol is Pb. Lead symbol is Pb. Last one is mercury, and its mass is, or the Latin name of this mercury is hydrogram. Okay, hydrogram, and its symbol is Hz. Is it clear? So let me stop in this session for today, and in the next session we'll continue with atomicity. Okay, what we will do? We'll continue with the atomicity in the next session. Okay, take care. See you in the next session.